What's up, everybody? Good morning. Coming back with another live stream from Scalar Learning. And today we are tackling more SAT problems from Khan Academy, which, in my opinion, is one of the best resources for SAT math problems. And we're moving on to structure and expression. So again, if you're new to the channel, we do live streams for the SAT every Saturday and Sunday at 7 a.m. PST. So I'm going to be blazing through 5 problems. I do them in real time, solving them for the first time. I haven't seen these problems before, and that's part of the points, is that you can watch the problem-solving process live. And guys, make sure to click the like button if you do like what you see. Definitely subscribe if you want to see more. Here we go. 2m equals x, 7n equals y. Which of the following is equal to 784mn? Okay. So let's see here. 2mn. Okay, so 784. This is I'm going to do a little prime factorization because I got to break down. I'm sure this is some product of a number of 2's and a number of 7's, but I don't know exactly how that works. So this is how I'm going to work it. 2, and that's 392, I believe, right? 600. And then 2 again. So that is 196, right? 196 is 3. Yeah, that makes sense. And then split it again. And it's 2 and 98. And then it's 2 and 49. And there's our 7's. Boom. Okay. So what this means is that 784 is the product of 2, 4, 8, 16. 16 times 7 times 7, which is 49. Or we can write this another way. It's 2 to the 4th, right, times 7 squared. Okay. Now that we know that, we can so what would equal this, right? Well, since x equals 2m, and we're trying to get something along the lines of 784, really what we're talking about is we want 2 to the 4m power, right? And 7 to the 2n power, which means that if I've got 2 to the m equals x, okay? And you see how m is in the final answers. That's why this is a pretty bizarre but tricky question, but doable. So now we're like, wait a minute. I know to get this 784, so what I need to do, wait a minute, hold on, let me think one more second, because, and then the exponents add. Wait, but those exponents multiply each other. That's the only weird part. Okay, let me, I almost feel like this is a mistake, but let me keep going. So this would be x to the 4th, right? Oh, wait a minute. This is a little trickier now than I thought. Hold on. 49. Got it. Okay. They need to have, it's like they need to have the same exponent eventually, 2n, because you can't just get those exponents together. That's the thing that's weird. So if it's 4n, okay. Anyways, let me just keep going down this train of thought and see if this makes sense. So this becomes x to the 4m, which means that would be 2m to the 4m, which is Oh, now I'm confused here. Hold on. So I was thinking it has to be x to the fourth power of some sort, like one of these, and y to the second power of some sort. Okay, let me go back to these two answers. So I'm feeling like it's either C or D, right? Because we need to raise 2 to the fourth power. Now the question is it 4m or is it 4n? So let me actually just plug these in. This is what I'm going to do. So I'm going to plug 2m into this guy. This becomes 2m to the 4n times, and then y is 7n to the 2m, okay? Then this becomes 2 to the 4mn times 7 to the 2mn. And then, let's see, how do they combine this? Because, okay, I get it now. And then this becomes 2 to the, so then we could call it 16 to the mn times 49 to the mn. Like I'm feeling like this is the right answer, but, and then but you can't, oh, I get it. Yeah, it's D. And then, so going from this, you could then say, well, this is just really 16 times 49 to the mn. You see what I mean? And then we can just multiply these guys together, and we get the 784 to the mn. So whereas this one, if I plugged it, I'm just trying to think real quickly, I'd plug in 2m and it'd be like 5m. Because it'd be 4m squared. This would give us m squared and n squared. That'd be different. This wouldn't work. It's definitely got to be D. Okay. This is a very difficult exponent problem. Let's see. Yeah, I've never seen anything like that on the real SAT in terms of that complex. There's things like it, but that's pretty confusing. Okay, next. P plus 7 over 7, P minus 7 over 7. Which of the following is equivalent to this expression? Okay, here's what I'm going to do is I see that these guys, every single answer, with equivalent expressions, I'm always going to look and see what the answers are. And you notice that every single answer is one expression over 7. I'm just going to get these guys to be one expression over 7. Now, this is actually a pretty good problem because they're just trying to get you on a little trick, and it has to do with that minus sign. So when we see a minus, really what we need to do is we need to immediately inject it and distribute it across the numerator and to just turn it back into a plus. So then it's like P plus 7 plus negative P plus 7. And I want this so they're both common denominators. Now we can just simply add the numerators. P plus negative P, 7 plus 7. The P's end up canceling out, and we just get 14 over 7. Which is 2, but I think what they had in the answer was 7 plus 7 over 7 plus 7 over 7. All right, next. Which of the following is equivalent to the expression above for x does not equal negative 3? And I'm going to look at the answers really quickly. So these guys, they've multiplied. And here they factor this. Okay, I'm just going to go for it and start trying to combine things. Can this be factored, first of all? I think the top one can be factored. Don't think that helps anything, though. Hold on, let me see. Yeah, you know what it does, I think. Okay, so let's factor this guy. So we need to get... multiply to negative 8, add to negative 2. And I think that can be 4 and 2, negative, positive. This multiplies to negative 4, adds to negative 2 when we add these guys. So that's correct. And I'm just going to connect everything together because they're all multiplying anyways. So this x plus 2 is that one. And then we've got x plus 3 like this. So it looks like we're not going to be able to cross anything out. And the only thing we could do is these guys are the same expression. So I could rewrite this as x plus 2 squared times x minus 4 over maybe x plus 3 squared. But anyways, let's look at the answers. This one's almost right. Right, they have the x plus 2 squared, x minus 4, but where did the extra x plus 3 go? It disappeared, so that's wrong. This one's wrong. I don't even know what this is with the factoring out of the 2's. That doesn't make any sense. This one looks good. Because look, if I square this, if I FOIL this out, it becomes x times x is x squared, 3x, and 3x makes 6x, plus 3 times 3, which is 9. So it becomes this. I know it's one of these two now. This doesn't make sense because I don't know how they factor a 2 up, but this does, right? This is what we looked at for the top. We can see it right there. So we can go here, and that's it. Next, which of the following is equivalent to this expression? All right, again, all right, they're either all over 2 or over 4. So let's see, and they're all factored. Okay, I think what we can do is factor out. Hold on, let's do it like this. I'm going to put both of these w's over 2 as well, because I think what they're trying to do, try and get everything under 2 and then pull out a 1, or everything, yeah, over 2, and then pull out a 1/2. So I'm going to change that to w over 2 minus 3 over 2 times w over 2 plus 7 over 2. Then I'm going to pull out a 1/2. Right, wait, can I pull out a 1/2 for everything? I think so. Oh, let's do it like this. Here, watch. W minus 3 over 2 times w plus 7 over 2. I'm just trying to think if that works. If I'm like, oh wait, I'm sorry. I can't just put this over 2. I'm messed up. It's got to be 2w over 2, because otherwise I'm fundamentally changing this. 2w over 2, because it's the same as w, right? 2w over 2 is w. 2w over 2 is w. So now it's 2w minus 3 over 2. 2w plus 7 over 2. Okay. And then, that's why. Got it. Okay. We can't. We can't pull a 1/2 out. That's what I was struggling with. I'm like, I think we can pull a 1/2 out. You can't. It's gotta. These guys are still multiplying each other. So these denominators, to combine everything, it's got to be 2 times 2, which ends up becoming 4. So we don't have to FOIL this because they're not doing it in the answer. But it's 2w minus 3, 2w plus 7, and then these guys multiply to become 4. And they just have it reversed, but it should be the same thing. Okay. Last but not least, this one. Okay, looks like they just factored it. All right. So this looks pretty tricky, but it's actually, I don't think it's going to be too bad. It seems potentially confusing because of the sheer amount of variables, but I bet it'll be all right. So what I'm going to do is, since we want to end up, oh, wait a minute. I see that there's a really easy shortcut here. At first I was going to distribute everything and so on, but no, that'd be the wrong move. Now I realize this is like a factor by grouping. So look, important thing to recognize is this term and this term are really the same. It's just they're flipped. So what I can do is I can take this negative, and I can kind of like, either way, I can factor out a -1 or distribute this however you want to think about it. So if I factor a -1 out of this, becomes c times ax minus b. And then factoring a negative out of this, it's like, imagine if I pulled a -1 out of this expression. To make it the same, this would be negative, this would be positive. You see how it flips, right? Negative times that, negative b, positive ax, which is the same as this. But pulling a -1 out, interacting with that minus, they cancel each other out. And now it's plus d times ax minus b. Now look, we've got this really nice thing here where this is multiplying by this and this. So let's factor out the ax minus b. And it's, you see how it's multiplying this guy and this guy. So now we have c plus d, and that's the factored form. Just like this. Now, if you wanted further proof that this is correct, I could go ahead and foil this, and then make sure they're equivalent. You know what? I'll do it anyways. Why not? Just to prove. Boom, boom. This becomes CAX minus BC. This becomes minus DB plus DAX. Okay, now let's foil this. This times this becomes CAX, same thing. AX times DAX. I'll put that at the end to match with that. And then this is negative BC right there. And negative B times D is negative BD, or I'll call it negative DB. Same thing. Order of multiplication, commutative property doesn't matter. So there you go, and that's further confirmation that that's correct. Okay. All right. That is it for today's live stream. I hope you found that helpful. If you did, please click the like button and definitely subscribe if you want to see more from the Scalar Learning channel. Oops, what's this? All right. So what's up, Akil? Again, if you guys are prepping for that upcoming SAT, you want to be aware of everything that's coming out from this channel. We got other test prep material coming down every day, 5 days a week as well. ACT on Mondays, IC on Wednesdays, and then, of course, our minute study tips on Fridays. Thank you guys so much for joining, and I'll see you all next time. Take it easy.